大家好，我是 Aptos 的 CTO 和梁创 Avery，很开心与中国的朋友们见面。I am also a fifth generation Chinese American. While I studied Chinese in high school, unfortunately, I'm well out of practice, as you can see. I'm excited to introduce you all to the Aptos blockchain. We are the layer 1 blockchain designed for everyone, prioritizing safety, security, reliability, and upgradability as core priorities. I've spent over a decade leading engineering teams at Facebook, now called Meta, most recently as the technical lead of the crypto platform team, which included the company's Web3 projects in general, wallet infrastructure, ecosystem projects, and most notably the DM blockchain. My team and I have been working on blockchain infrastructure since 2018 on cutting-edge consensus protocols, network storage, parallel execution, programming models, and researching a wide breadth of technical solutions to help Web3 reach billions. Prior to this, I was the overall tech lead of all of Meta's batch processing teams, including Spark, graph processing through an open source project I co-created called Apache Giraffe, Facebook's Hive and Hadoop, distributed scheduling, and unified programming models. These technologies power analytics for all of Meta's projects and scale to hundreds of thousands of machines. I was born in Honolulu, Hawaii, and completed my undergraduate PhD studies in computer engineering at Northwestern University. My doctoral studies focus on the broad areas of supercomputing, parallel computing frameworks such as MPI, MPIO, and parallel distributed file systems. In short, I'm really passionate about scalable infrastructure. The last 4 years of my life have been focused on blockchains, as I believe they are a key enabler for empowering society to govern and manage the infrastructure they use, as well as the assets within it. When we think about what enabled the internet to reach billions of people in so many areas of our lives, including social media, finance, gaming, shopping, and streaming services, the answer comes down to 3 things: intuitive, instant, and inexpensive. We are early in the journey of Web3 infrastructure. We are in the dial-up phase of internet access. All of the existing blockchains combined can't support what a single MySQL server can do today. And consider that companies like Google, Meta, and Amazon have hundreds of thousands, if not millions, of MySQL servers to support a single application, such as web search, social media, and online shopping. Web3 will eventually have such applications that reach billions, and imagine the amount of raw hardware required and complex decentralized software working in tandem to support this new world. Public cloud infrastructure has been the backbone of scalable and reliable internet services. Data centers worldwide support virtualized and physical servers, serverless compute and analytics, and a variety of flexible pricing models. This infrastructure has enabled an explosion of internet services for every industry, and startups need to focus on application development instead of infrastructure scaling. Our industry needs to provide that core decentralized infrastructure layer to do what cloud services have enabled for the internet. What's even more exciting is that decentralized infrastructure enables applications to interact with each other in a way that centralized services cannot. People can move assets between platforms and transact with different communities without intermediaries. Many of the exciting new use cases are yet to be discovered in social, gaming, finance, media, and entertainment, as well as cross-cutting use cases between them. In summary, we believe Web3 applications need to be intuitive, instant, and inexpensive, and we need to reimagine the entire blockchain stack to provide the new building blocks and enable the new user experience required for large-scale adoption. Starting off with our core design decisions at Aptos Labs, we kind of have to go back 4 years ago. 4 years ago, we were thinking about what a blockchain and a Move smart contracts language would look like to support billions of people. We came up with Move as a new way to think about how to improve the developer experience, both from a safety aspect and a developer infrastructure experience as well, and onboard as many programmers as possible. We thought about how we are researching new different types of technology and how that technology could be used in different ways, but we weren't sure exactly what the trade-offs should be made depending on the use cases that are for the future. And therefore, upgradability and configurability would be the most important design decision to make sure we bake into the protocol from the very early times. As far as hardware utilization, we know the value operators are very concerned about the amount of cost that's necessary to run these machines, and taking the best advantage of their hardware is something important, not to them only, but also to the users and developers in the system. And so we developed a unique modular and pipeline approach to transaction processing. Parallel execution is something that can support high throughput networks. And we think we've developed an interesting technique through block STM, which allows you to support atomic transactions with high complexity, and yet be able to get extremely high throughput. And finally, in order to kind of reach large-scale applications for Web3, we support different types of sharding solutions, both intervalidator as well as intervalidator. Going back to intuitive and what that means from user experience, we kind of started on 4 different paths to explore. The first of which is key management. It's been estimated that 10 to 20% of all Bitcoin funds are locked up in unreachable accounts. And this is something that we're really concerned about for the user experience. So out of the box, Aptos supports key recovery for any key rotation for any account, And we've been looking at different ways to support different kinds of methods that would meet different user needs. For example, today we support a method where a user can actually delegate their key rotation to a third-party contract. That third-party contract could support hybrid experiences where, for instance, if the user has not transacted on chain for a period of time, that third party can actually rotate the key on behalf of the user. All of this would be transparent. It would be something that's supported by a wallet. And better yet, since it's baked into the L1 layer, any wallet can actually take advantage of this feature. Transaction viability is something else that we've thought about from user experience. Typically, when you sign a transaction, you kind of make it valid for all time. That's not very safe. And so instead, we think about how we put limits on the transaction viability through expiration times, through sequence numbers, and limiting the damage that's possible when someone signs off on a modification to the blockchain. The third area we focus on is how do we make sure the users are aware of what's going on when they sign a transaction. And so human readable transactions are something that are very important to us. We've actually developed a technique where we can simulate transactions onto our blockchain and tell users exactly what's being modified, what assets are being transferred, what smart contracts are interacting with. And this provides a lot of transparency to know what's happening before you sign your transaction. Finally, when wallets are interacting with the blockchain, typically they're just doing so over TLS certificates and kind of trusting the servers at the other end to tell the truth. Line-climb proofs are a way to kind of secure that last mile security, and combined with a very fine-grained timestamp, a high granularity of confidence that you're near the head of the tail of the blockchain when you check your data. Let's talk more about Move. Move is designed as a smart contract language built from the ground up. And when we thought about the things that were important for smart contracts language, it was being deterministic. It is metered execution to make sure there's no denial of service attacks. And it's also to support resource scarcity in a way where it doesn't rely on programmers, but relies rather on infrastructure itself to support that. And finally, we thought the Move proof would be a very cool tool in which you can actually formally verify application-specific semantics without just relying purely on auditing methods. Move supports resource safety. It avoids resource duplication, double spending, any unintended destruction. And we know that in Chinese-speaking regions, Move actually has a very long history of development. It's been used in other networks. We've seen lots of Move developers in those areas being able to develop contracts. There might be hundreds or even possibly thousands of developers in that space. We're really excited about having seen some of those developers come over to Aptos and build on top of our network. Finally, Move is platform agnostic. It supports different kinds of consensus protocols. It supports different kinds of account models, UTXO and others. It also supports different ways of doing things within the Move adapter, which are customized to specific blockchains itself. And we're really excited about the future of Move and where we'll take Move in the future as well. Upgradability, as I mentioned, is a very key component of the Aptos blockchain. If we can almost strip away almost everything except for upgradability, and we think we'd be really excited about what we're building here. And as I mentioned earlier, the reason is because we've got a long line of research already in the history of blockchains around consensus protocols, and we're still seeing tons and tons of new development in that space. You can check out what Roddy and Sasha have done in our team with respect to their history of DAG-based protocols and the new things in the future, for example. We also see new Turing models coming into play. We have block.stm coming out. These technologies are all not ready today. And we want to make sure that we be able to support new things and new ideas in the space quickly to support those new use cases that develop over time. The way we do this actually is by storing the on-chain state within Move on our blockchain itself. So clients can actually sync the state of the blockchain and also determine exactly what the configurations are and know exactly which consensus protocol to use, what features are now available, as well as, if you want to change signature schemes, for example, all those things can be done. And we built in governance tooling to support and facilitate these changes in a decentralized environment, which happens extremely fast and efficiently. This is not something that's just theoretical. It's something we've done in the past within kind of private mainnets before multiple times without a hitch. And we've done actually more recently in our incentivized testnets. One of the radical changes we had from the original tech stack was the way we think about transaction processing. And the reason why we thought that was, how do we get the best use of hardware from the validators? And how do we enable high throughput and low latency infrastructure? And the way we drew inspiration from was from kind of modern day CPU, superscalar CPU infrastructure and architectures, where you get a high frequency because you split up the transaction processing across many different stages. And these stages can be superscalar. In fact, they can have multiple AUs happening in a single stage, multiple computations happening there. And I think there's a lot of parallels to draw within our architecture as well. So our transaction processing has been split up into 5 different stages. We have continuous transaction dissemination, block ordering, parallel execution, batch storage, and state proof certification. And I'll walk through each of these individually. I think something to note here, though, is that these stages are not dependent on each other. They can all operate independently. They can all be parallelized, and they can all take advantage of the hardware that's available to them. So in the first phase, continuous transaction dissemination, a validator will continually send blocks of transactions to other validators and produce what's called a proof of availability when others are willing to kind of certify that they've stored this data, they're not going to remove it. The next phase is that we take these blocks and validators then propose that these blocks be committed with respect to ordering. And this is not with respect to transactions themselves. So a common misnomer is that consensus is slow. In fact, consensus is not slow. It's simply agreement. And as long as you don't stuff in other things that don't belong there, such as the transaction dissemination, the execution, the storage, consensus is actually very fast. And in this case, we just agree on the metadata. We don't agree on the transactions, the execution of that, or any of the like. This happens in parallel as well. Finally, the next stage is going to be going to parallel execution. And at this point, you have an ordering of data. You have the opportunity to actually reorder it again, as long as validators all agree on that ordering. But this is simplifying things for a second. Validators are going to execute transactions in parallel through software transactional memory libraries with optimistic concurrency control using the block STM, as I suggested. And this allows us to get extremely high throughput from our network. Another thing that's great for our efficiency is thinking about batches. And batches are something that we do continuously throughout the system. Batching is an efficient optimization for when we think about signatures on batches versus single transactions. When we think about the way we do writes, in this case, you have a global state change. And by doing this global state change and then writing in bulk, you save on IOPS, you write larger chunks and get better bandwidth. Any kind of overlapping writes are eliminated from the write path completely. Just taking much better use of that hardware. The final phase is how do we certify proofs? We want to make sure we generate the authenticated data structures around ledger history and ledger state. And this is useful for light clients. This is useful for state synchronization, for auditing, all kinds of other purposes. I'd like a chance to talk about the way we do prosecution, which we think is very differentiated from the rest of industry. It's common in most cases where other parallel runtimes will kind of declare upfront your read-write dependencies in order to kind of simplify the process of determining what can be parallel executed and what cannot be. Block STM doesn't have that restriction. It takes kind of whatever sequential and can still operate and infers that parallelism without the programmer's assistance. What this means is that for transactions where you kind of don't know exactly what you're running to, for instance, in auction, we don't know the winner, you actually can do this in a single transaction with block STM, whereas with other engines that require that read-write dependency, that has to be split across multiple transactions. So this is something that preserves atomicity for programmers, makes it much easier. And the way we do this is through an optimistic approach. We use a multi-version data structure, look for dependencies, and kind of re-execute when necessary if there are overlaps. But block STM can also take advantage of other cool techniques, such as reordering, as long as we agree on ordering of validators to maximize parallel execution, or maximize gas fees, or maximize whatever we'd like to do at this point in the processing pipeline. The final thing I'd love to touch on, which is coming soon, is really our thoughts on sharding. And so when we think about the future of Web2 applications, you need scalable decentralized infrastructure. It can't just be a single machine going forward. And so any parallel computing environment can scale. Now, the question is whether you want to do it externally or internally. We are taking a pretty interesting, unique approach to horizontal scalability while maintaining decentralization. We will be exploring both paths, by the way. So making validators that are more powerful or split across multiple machines, as well as examining the thought about how do we think about almost like a sharded MySQL concept. And the cool thing is that Move can support shards as a first-class concept. And as I mentioned earlier, Move can be extended to support different kinds of querying paradigms. You can imagine you have homogeneous bridging supports between shards, or even shards that have different kinds of system characteristics, shards that are really good for compute, some that are great for caching, and some that are great for storing large amounts of cold storage. And I think the idea is that we want to make them linked by a single token. We're really excited about the community coming together within Aptos. And we started our project in March, launching our DevNet and inviting developers over to our office and hacking with us in May. And just a couple months later, we've got more than 200 projects building on top of us. There are more than 70 plus NFT plan launches, lots of people checking out the GitHub, many people interacting on Discord and Twitter. Our testnet traffic actually is incredibly high. We see more than 40 transactions per second from users, more than 3.5 million transactions a day. And some of these projects are so imaginative in terms of being in DeFi or NFTs or in social communications. We're really excited about the folks that are coming together to build together with us. And this is a community first project and something that we're excited to see coming together so quickly. We'd like to walk through our timeline right now. in mid-March, we launched our developer network and had people playing around with Move and getting familiar with the environment, joining Discord, all those fun things. In the next couple of months, we actually got a chance to work with the community on running incentivized testnets, from decentralized startup to staking to governance and upgrades. And we've been really excited to announce that EIT3 is actually completed, and we'll have the results coming shortly. We do plan our lunch in autumn, and as I mentioned earlier, upgrades are something key to our technology stack. We have a number of different exciting ideas in this space they want to continue to push out. We expect those to come out every 4 to 6 months. And our goal is to keep the community building on top of the latest and the greatest technology stack going forward. In conclusion, we're really excited about the technology we're bringing to this space. We care deeply about this market. APAC is an area very core to myself, to Mo, to the whole team. And we are going to be building out a dedicated team within this region to support development and growth. We ask that you please reach out to us, and I hope to meet you all soon. Thank you.